Greetings, Royal Family, and welcome back to another fun African math play session. We're going to have fun playing a fun game called the African Math 10 frame game, and we are going to start by counting 1, 2, 3, 4, and we have 5. That's awesome. We have 5. We're going to draw out our ancient African numbers for 5. The ancient Egyptians used tally marks. This is our modern international number for 5, and we're going to draw out the quantity. 1, 2, 3, 4, 5. So we have 5. And now we have our counting toys to match the quantity. We use another symbol for 10. So we call our counters bits. We call them, some people call them ones. Some people call them units. But we call them bits. So instead of ones, we're going to make this a B for bits. And then we're going to have place over here. This is tens. This is where we put our tens. So for the African abacus, we're going to use the B's for green and our tens go here. Okay, so you see that symbol? The symbol here that represents an Nguni house of 10. The ancient Nguni houses look like this in ancient Africa, and it was embedded into the ancient Kemetic number system. So if you go look up ancient Nguni houses, you'll see Bantu and Nguni houses. You'll see this image, and it also represents a African arch. So if you go look up Nubian vault or African arch, you'll also understand that this symbol right here was used. It's a physics. It was used to displace the weight of the building so that the weight of the building would not collapse the doorways and window openings. And that's why this symbol was made into metal netter, for the reasons of reminding learners about the house of 10. And now that we have a 10 here, we would write the number 10. Ancient Egyptian numbers were not really positional. You can write the numbers any way you like. But our system here in the United States, internationally, our international numbers require that you write the value in a specific order. So this is for place value. So there's the positional place value. So you have to position tens to the left of bits, so that we have 110 here, and we have 110 here, and then we have 5 bits here, and we have 1, 2, 3, 4, 5 bits here. Now, what's very important when you're doing a Bitric 10 system, because we have multiple place value systems here at Bitric. Bitric stands for the Benjamin Banneker Institute of Technology, Research, and Innovation, headquartered in Washington, D.C., which is where Benjamin Banneker surveyed our nation's capital and arguably even designed it. We use the Bitric system based off the ancient Egyptians' number system as well, and they had different units of measurement. Like the foot was used, they used the yard, they used body parts, they used the arm, they used the hand, and they had a unit of measure. They would group units of measure according to the body parts, because that made it easy for learners to understand. So here we have a hand. Okay, now I'm gonna go get some new beads. No, let me see. Let's use our yellow bits that we have. I'm gonna use the yellow beads right here, and I'm gonna put a bead in the hand. Now, can anyone guess what quantity the hand represents. Okay, if you said 5, then you are 100% correct. Now, the advantage of having a hand is it helps you quickly group a quantity. So if we have 1, 2, 3, 4, 5 beads, okay, we have 5 beads. And if we say, okay, now let me add 3 beads to it. Okay, so we have to first count in and disperse 5, 6, 7, 8, which is great. This is awesome. This is great for one-to-one correspondence. It's an advantage of the African abacus because early learners can learn how to count 1, 2, 3, 4, 5, 6, 7, 8, and it helps with arithmetic. Now notice I'm going to remove 2 of the beads. So we have 8, 7. Now we have 1, 2, 3, 4, 5, 6. The advantage of having the hand as a unit of measurement is because now instead of having a fraction of 5 represent a quantity, we can have a group of 5 represent the quantity. So now we put the hand here and it represents 5. The way we typically group in the Bitric and African math system is we use a process called clear carry, where we clear the fraction of a value or a quantity, and then we carry in a group. So we're going to clear fractions of 5. We're going to clear 1/5, 2/5, 3/5, 4/5, 5/5. So we're going to clear 5/5, and then we're going to carry in a group of 5. So now we have 5 put together with 1 down here, and that's the same as, can anybody tell me what comes after 5? Okay. So let's draw it out. Okay. We're going to first draw out 1, 2, 3, 4, 5, and then we're going to put together with 1, and the answer is 6. Because we have a hand here put together with 1 bead, it's the same as 6. These represent fingers. 1, 2, 3, 4, 5 fingers, and then we have a bead. For the African math system, you can use either a tally mark or a dot to represent bits. The tally marks and the fingers represent fingers, the digits represent fingers, and then the dot represents beats. If you want to take away, all you have to do is draw a circle. Our negative symbol is a circle. So if we wanted to say take away the 1, okay, we can either take away 1 bead or we can put down 1 finger. It's as long as we get the correct answer. So what I'm going to do is I'm going to take away the bead. So I'm going to circle the bead, making a 0 pair, because now a positive put together with a negative is the same as 0. And we're going to clear, we're not going to carry, we're just going to clear away our positive bead, making a 0. Now, we just jumped into subtraction. Again, we're going to clear the bead from the board. And now we have 5. 5 here. I'm clear here, and then we're going to have this represent our 5. So now the reason I'm doing that is because whenever you have a hand next to a row, it could be the upper row or it could be the lower row, as long as you have a hand next to it, is an indication that you've activated all 5 cups. Okay, so instead of having to have 1, 2, 3, 4, 5 beads, we can just add a nice hand toy that represents 5. Now let's say we want to put 5 to, well, let's say we want to put 5 together with 3. Okay, so we have 5 here, and then we're going to do something that's called counting on. Okay, so we're going to count on from 5. So we have 5, 6, 7, 8. So 5 put together with 3 is the same as 8. And we can put those in our African abacus. So now we have 5 put together with 3. 1, 2, 3. Counting on from 5, 6, 7, 8. And that's the way you can quickly add 5 and subtract 5 without having to load the African abacus with that quantity. So it's more efficient where you have a group, and that's why groups are so important. If we had to count everything by ones, then our society would not be as efficient. If we had to count, if we imagine if there was only $1 bills, or if there were only, we had to count everything out by pennies or dimes, or even if we had to count everything out by quarters or dollars. That, I mean, imagine having to count thousands of dollars for transactions or hundreds of $1 for transactions. So to prevent that, we make groups that represent a larger quantity, a larger value. So this system goes back all the way to ancient Africa, where we would create groups that were based on the values of our body ratio. And we're going to get more into that. We're going to learn about other body ratios, the cubit, which was represented by the arm. We're going to talk about the foot, which is represented by the foot. And then the palm. The foot is 12 parts. The palm is 4 parts. And we're going to have fun with that in later lessons. Until next time, until we have those lessons, I want you all to remember, what is education? Education is preparation for the next generation to inherit their nation. Until next time, happy learning.